Hello students, in this lecture I will talking about the basics of the information theory. The topics like entropy, channel capacity will also be included in the video. So let us start from the very basic. So let us start from a communication system. In the communication system, first a source will generate a video or audio or any type of signal. So that signal, as our communication system is compatible with the electronic or electrical components, so the signals has to be converted into the electrical or electronic form. That is done by the input transducer. Then the converted signal that will come to the transmitter. Transmitter will do two things. One, it is modulating the signal and it is encoding the signal. So the encoded and modulated signal will come to the channel. Through the channel, it will be transmitted to the receiver. And within the channel, there will be introduction of the noise distortion. Okay, so at the receiver, the first thing is to be done that the receiver will reduce the noise. Okay, then it will demodulate, then it will decode the signal. Then the signal is in the electrical or electronic form, that it has to be converted into its original form. That is done by the output transducer. So it will come to the output transducer, the conversion will be done, and then converted signal that will reach to the receiver destination. Okay, so this is the basic communication system. Now, in this basic communication system, which is transmitting, information is being transmitted from a source to the receiver. So information is a very important thing for the communication system. So now, what is information? That is the first question should come in our mind. Okay, that information theory is a scientific study of the quantification, storage, and communication of the digital communication or analog or any type of communication. The field was fundamentally established by the work of Nyquist and Hartley in 1920s and Shannon in 1940s. The field at the intersection of the probability theory, statistics, computer science, statistical mechanics, information engineering, and electrical engineering. A key measure in the information theory is entropy. Entropy quantifies the amount of the uncertainty involved in the value of the random variable or in the outcome of the random process. For example, we can say what will be the outcome of flipping a coin? There will be two equally likely outcomes, head or tail. It provides a less information compared to the phenomena of rolling a die, where 6 possible outcomes can come. Okay, some other important features in information theory are the mutual information, channel capacity, and the relative entropy. Important subfields of the information theory include source coding, algorithm complicacy theory, algorithm information theory, information theoretic security. So, what are the applications of the information theory? The fundamental information theory includes source coding or data compression that is done in the zip folder. Channel coding, error detection, correction. This is the common application. It has a great impact in space communication also. Its impact has been crucial to the success of the Voyager mission to the deep space. Okay, feasibility of the mobile phones and development of the internet. The theory has also found application in other areas, including statistical interference, cryptography, thermal physics, molecular dynamics, quantum computing, black holes, in various fields. Okay. So information theory studies the transmission, processing, extraction, and utilization of the information. In the case of the communication of the information over a noisy channel, the concept formalized in 1948 by Shannon in the paper that is a famous paper, that is a mathematical theory of communication, in which the information is thought of a set of possible messages, and the goal is to send a message over a noisy channel and to have the receiver reconstruct the message with low probability of error in spite of the channel noise. That was its motto. Shannon's main result, what was the main result? The noisy channel coding theorem showed that in the limit of many channel uses, the rate of information that is asymptotically achievable is equal to the channel capacity. That is a quantity dependent on the statistics of the channel over which the messages are sent. Coding theory is concerned with finding the methods. It is called codes for increasing efficiency and reducing the error rate. These codes can be roughly subdivided into the data compression and error correcting codes. Okay. Now, as we are discussing the information theory and relevant topics, we should discuss about the history, some history which is behind the information theory. Okay. Information theory idea was first developed in famous Bell lab. So Nyquist, the father of the information theory in 1924, studied the telegraph communication and derived a relation regarding the speed of the communication, that is W equal to K log of M, where W is the speed of transmission of the data. M is the number of different voltage levels and K is a constant. Okay. And Hartley, in 1920s, they have done the research on the information theory. In Hartley in 1928 paper, transmission of information, uses the word information as a measurable quantity, and he quantified the information as H equal to log of Sn or n log S, where S is the number of possible symbols and is a number of symbols that is transmitted. The unit of the information was therefore a decibel digit, which is sometimes called the Hartley in his honor, or the scale of measure of the information. In Shannon's revolutionary and groundbreaking paper, the work for which he has been sustainably completed at the Bell labs by the end of the 1944, Shannon for the first introduced quantitative and qualitative model of the communication as a statistical process. And the assertion is the fundamental problem of the communication is that of reproducing at one point, either exactly or approximately, a message selected at another point. Okay. So information theory is based on the probability, as Shannon introduces the statistical approach to the information theory. So information theory is based on the probability theory and statistics. Information theory often concerns itself with the measure of the information of the distribution associated with the random variables. Important quantities of the information are entropy, a measure of information in a single random variable, and mutual information, a measure information in common between two random variables. Now we can use this formula for the measurement of the information theory. If the digital source generates the message M having the probability of occurrence P, then we can quantify the information carried by the message M. I is equal to log of 1 by P base B. B is the base of the logarithmic log. And so if P is in the numerator, we can say it is minus log of P base B. So in the information theory, the entropy of the random variable is average level of the information. Okay, it is the average of the information, or it is also called the uncertainty. Okay, so this can be quantified with this relation. H is equal to summation of P into log P. Okay. The concept of the information theory was introduced by Shannon in 1948 in the paper A Mathematical Theory of Communication, and is also referred this entropy as Shannon entropy in the honor of his name. Shannon considered various ways to encode, compress, transmit messages from a data source, and provided in his famous source coding theorem that entropy represents an absolute mathematical limit on how well the data from the source can be losslessly compressed onto a perfect noiseless channel. Okay, and again, as we are dealing with the information, so information rate is very much important. And the source, if a source generates R messages per second, the rate of information or the average information per second is dependent on the entropy of the source. So we can quantify the rate of information like R, capital R is equal to H by T. Okay, so T, capital T will be the time required to send a single message. Okay, and last of all, in the information theory, we can say something about the channel capacity. The channel capacity C is defined by the maximum rate at which the information can be transmitted through the channel, and these channel capacity is basically dependent on the mutual information. Okay, mutual information is denoted by I, X, Y. Okay, so C is equal to maximum information still can be carried through the channel. Okay, so we can say C is equal to max I, X, Y, and obviously its unit will be bits per message. Okay, so this is all about of this video lecture. So this video lecture will be uploaded in the portal. Please go through it. We will discuss the doubts and we will do a question answer round in our physical classroom. Thank you.